Okay, so what was I saying? So all that you first thing you must do when you do matrix multiplication is to check the size of the matrix. And the size of this left matrix is what? 2 by 2, right? 2 by 2 means number of rows. Hashtag means number of rows. This one is number of columns. Over there, the second matrix on the right side, it's 2 by 1. So what is the same? What is the same? This pair is the same, okay? You have to check that this pair over here, number of columns of the left matrix and the number of rows of the right matrix is the same before you can do matrix multiplication. If it's not the same, it's undefined, no solution. So how do you do this multiplication? Do you recall? Row by column, row by column. Can you remember? How? What's the resulting size?
2 times 1.
2 times 1, good. So that means you have 2 rows and 1 column. What's the first entry? What's the working? Row 1 times, okay, look, this is 2 by 1, right? So there's row 1, column 1, this guy. Row 2, column 1, that guy. Can you see?
Okay.
Row 1, column 1, this position. Row 2, column 1, that position. So let's start with this position. What's the name again? Row 1, column 1?
Row 1, column 1.
So row 1, column 1 means you take row 1 from the left matrix, column 1 from the second matrix. Then you pair them up, you multiply. First with first, second with second. Can you see the pattern?
Yeah.
If I highlight it, means yellow with blue, this will become, erase away.
17.
Yeah, correct. So it becomes a 1 times 5 plus a 2 times 6. You simplify it, it becomes a 17. Yes. Next one.
39.
Yeah, correct. Good. So it will become green times the blue. This will become, write down the working, 3 times 5 plus 4 times 6. Then you get, what is it, 15 plus 24, 39. Yeah. Good, you remember already. Okay, now we apply it to this case. Can you see that you can convert this into a matrix? Can you see that it's already just 4, negative 7, 8, 5, and then you multiply it by x times y, and it's equals to 15, 11. Can you see how they are the same?
Yeah.
Right? Because you take, I follow the exact same color notation. Yellow.
It's
green.
basically 4x minus 7y.
Exactly,
After
right?
you times in, then it becomes 50. Yeah, okay, I see it.
And 8x plus 5y equals to 11. Okay. So we have converted it from a equation world into what we call the matrix world. And this is what I call the ax plus b format. A times x equals to b. What's A? A is a square matrix like this, which is also known as the coefficient matrix. Because it contains all the coefficients of the numbers, right? That's why it's called a coefficient matrix. Okay. Then this guy is called the solution matrix. Or actually vector. If it's only one column, we call it a vector, a special kind of matrix. Right? Vector, you have learned before in O-level Emacs, hopefully. 2, 3, and this is vector 2, 3. You learned before. Wait, were you part of the you got learned before? Yes?
Yeah.
Yes, okay, good. But it's now a solution. It's a solution to the equation. Then this B is called the constant. Just right hand side, just the constant vector matrix. Its tilde notation must be drawn because vector is different from a scalar. You have multiple scalars inside a vector. Okay? So what this means is that if you think about an equation when we have, for example, I don't know, 5x equals to 25. How do you solve for x? You divide by 5, correct? But isn't that really just the same if I slow things down so that you can see a pattern with the compare with the matrix? Isn't that the same as the 5 is on the left? So how about if I put bracket and I multiply by the opposite of 5, which is 1/5? Then I multiply on the left, so I be systematic, I also multiply on the left. Then what happens to your 5? They cancel away, you're left with x equals to 1/5 times 25. Okay? But what's another way to write 1/5? Isn't it just 5 power negative 1? Isn't it just 5 power negative 1? Correct or not? 1 over 5 is the same as 5 power negative 1. So I can rewrite this as 5 power negative 1 multiplied by 5x equals to 5 power negative 1 multiplied by 25. Then 5 power negative 1 times 5 power positive 1, they will cancel each other off, become a 1, right? So it becomes a 1 here, then we're left with nothing. Or in other words, this guy, I don't write 1/5 anymore, I write 5 power negative 1. Then that will give you the answer if you just use a calculator. Correct or not? Understand what's going on? So what we are doing is essentially to go from here to there, we take the coefficient in front, we bring over, but we take the inverse. So same thing, similarly, not mathematically exactly the same, but wouldn't it be nice if we could just do the following? Ax is going to be, that's our 2 equations in 2 unknowns. It can be made even worse with 3 equations, 3 unknowns, 4 equations, 4 unknowns, 5 equations, 5 unknowns. The coefficient matrix, the solution matrix, and the constant matrix will still stay the same format. Ax is going to be. Wouldn't it be nice if we could just transfer the A over and we get A power negative 1 times B? Wouldn't that be nice?
Yeah.
Then we can just, if we have a formula for A power negative 1 times B, then we can just sub in and then just get the answer straight away, right? Make sense?
Yeah.
Then, do you learn this before? Inverse of a matrix?
No.
No, okay. Then I go through. So, and indeed there is a solution. But one more caveat I have to bring up is that your matrix multiplication must follow the order. Left times right is different from right times left. Do you understand that? Like left is a square, right is a column. If you swap the order around, is it still defined? It becomes 2 times 1 times 2 times 1 multiply 2 times 2. Can you still multiply? Yes or no? Let's check. Can we still multiply? Let's check. Ayo, this one. Wait a minute, 1 second. Need to change it to screen mode. Then I wait 3 seconds. Then it loads. And then I select. Then I can shift it around without moving. Okay. Found a bug. Okay, so what I'm saying is that if you swap it around 5, 6, multiply by 1, 2, 3, 4. This is 2 by 1. That is 2 by 2. Is it still defined? If it's not equal over here, this one is equal. Equal is a happy face. Okay, I draw it like this. If you have equality, then it's a happy face. This is defined. For the other case, when it's not equal, what do? You say it's undefined. You cannot multiply. Because you think about it, you want row by column, right? How do you get this 1 times 5 plus 2 times 6 is this row times this column. Then just nice, we got pairings nicely. We got pairs, a pairing for each of them. You see, 1 times 5 plus 2 times 6. But for the other case, you got row here, a column there. 5 can pair out with -1. Then who pairs out with the 3? Got no partner. Very sad. Right? You cannot pair out with 6 because it's always row by column, row by column. So there's no pair. This one question mark, question mark, question mark. That's why it's undefined. Is that okay? Can understand this idea? So the order matters. Left times right is different from right times left in matrix multiplication. You cannot juggle the factors around. Unlike in normal math with real numbers or 5 power -1 times 25, you can always swap it around, bring to the right side. Also okay, because left times right, right times left is the same for real numbers. But here we are not dealing with real numbers anymore. We are dealing with a different mathematical item known as a matrix. Okay, we're dealing with matrices now. So be careful. Your A inverse must be what I call left multiplied. In other words, you start off with AX equal to B. What we are doing is we are multiplying both sides by A inverse. We are left multiplying. This is called left multiply by A inverse. And then A inverse and A cancel away, you're left with the X equals to A inverse B. Can understand? Now we're gonna figure out what's A inverse. There's a formula for it. I'm not gonna derive it for you. I'll just tell you the formula straight up. So let's copy this down to a new page. Then I need to realize that this is really just AX equal to B. Now my objective is to figure out what's A inverse. So A inverse is the following. A inverse is 1 over the determinant of A multiplied by what's known as the adjugate of A. Adjugate. I'm not gonna give you the full definition of adjugate. I'm just going to give you the special case for a 2x2 matrix. Maybe I should have started with this. Sorry, let me try again. I start with A equals to A, B, C, D like this. Whatever number it is. In this case, A, B, C, D is 4, minus 7, 8, and 5. Later I show you the example. Then A inverse is defined to be 1 over the determinant of A multiplied by A and D here. I'm gonna swap their positions. So I end up with D at the top left, A at the bottom right. B and C here at the other diagonal. That's my D. Here. Okay, so over here, the B and C, I'm gonna multiply by a -1. Minus B, minus C. Can you see the negative sign?
Yeah.
Okay, this is the definition of A inverse. But what is determinant of A? I'm also gonna spare you the details. There's a full definition, okay, that requires a lot more work. I will just tell you the 2x2 version. So for the 2x2 version, the determinant of A is really just A times D minus B times C. And how do you get this fellow? It's really just from the coefficient, the matrix coefficient matrix, or just matrix A. You take this order. If I use a highlighter, should I use blue or use blue? Can you see the pattern? Take this AD, then you minus away the BC. Go in this order, AD, then minus away BC. Oh, that is your determinant of A. Then you multiply it by that fellow there, which is, let me use black pen. D minus B minus C and A. Now let's try and figure out what is this A inverse here, followed by multiplying by B. Later on, I'll show you. For the solution X, it will be A inverse times B. Let's see how this formula works. So we know the answer X equal to 2, Y equal to -1 already, right? Let's figure out what's A inverse. 1 over determinant of A. So what's determinant of A? AD minus BC, right? Can you tell me what's AD minus BC in this formula? I mean, in this example, following the formula. Tell me what it is. Fill in the blank. A is
4.
And continue. 4
times 4 times 5
minus
-7 times 8.
Okay, good. Outside the that's 1 over determinant A. Then we're gonna multiply by R. What thing? What do you do? Go from here to here.
Inverse.
No. We haven't filled in the blank yet. B, minus P, or minus C and A. And the trick is, you look at your original A. What do you do with this 4 and 5?
Same.
Same? No, look carefully.
Oh, flip.
Flip. So that means that it's 5 here, 4 there. Then what happens to your other diagonal?
7 and -8.
Good. Okay, then we calculate this. What's 4 times 5 minus -7 times 8? 4 times 5 minus -7 times 8. I use my calculator and I obtain the answer is 76. Okay.
Mm-hmm.
Now we're going to multiply it inside. So let's just make it ugly. Just do it, just multiply inside. Get 5 over 76, 7 over 76, minus 8 over 76, 4 over 76. I'm not going to simplify it. I know there's common terms you can cancel off. I'm not going to simplify it. Leave it. Next, we're going to solve for x. So x equals to what? A inverse b. Right? What does that mean? It means we copy down the answer from above, this A inverse. Then we're going to multiply by b. What's my vector b? What's my vector b? A is the square matrix, X is the solution, XY, B is the column, which is 15, 11. Okay, this one is fine, it's B. Do you understand the notation? A, X, and B. Clear? Yes, huh?
Mm-hmm.
Then you just copy the B down, multiply by B. Is this defined? Let's check. What's the size over here of this matrix? 2 by 2. What's the size of this other matrix here? 2 by 1. Anything same? Is the number of columns of the left matrix and the number of rows the same? Yes. 2 columns here, 2 rows here. Then it's defined. You can have this pair and this pair up nicely. Okay, so this is defined. Then let's multiply out. What do we get? What size matrix will we have?
You have a 2 by 1.
2 by 1, so 2 columns and 1 column. 2 rows and 1 column. Sorry, I need more space. I'm just going to draw a huge one. And then I draw a broken line like this. So you can see 2 rows, 1 column. Makes sense, right? 2 rows,
Yep.
1 column. Okay, fill in the blank for the first one.
5 over 76 times 15 plus 7 over 76 times 11.
And the bottom
And
row?
on the bottom is negative 8 over 76 times 15 plus 4 over 76 times 11.
Okay, let's calculate it. Help me. Calculate. Okay, wait, actually I can show on the screen now. I'll just do it. Okay, let's do it. So let's see what we get. 5 over 76 times the 15 plus 7 over 76 times 11. Wait, 2. 2, okay. No, 2 here, simplify. What about the other one? Let's try. Minus 8 over 76 times 15 plus 4 over 76 times 11. Wait, negative 1. Wow, so many fractions suddenly got one whole number. So weird. Negative 1, huh? Gotta write down negative 1. You can just type my calculator, minus 1. So what does that mean? X equals to 2, y equals negative 1 is your answer. Is it the same as above? Yes, huh?
Mm-hmm.
Magic. Whoa. Are you not surprised? Are you
I'm
not
surprised.
amazing, right? All this weird formula. What determinant A? Why is it called determinant? Determines what? Then suddenly you swap here, you times negative 1 here. Why does it give you the answer? I don't have time to go through the proof. It is based on elementary matrix and row reduction. It will take a few weeks to explain. Oh, okay. Tana, so this is called the Gaussian elimination using matrices. Want to try another example?
Okay.
Let's try one. Okay, give me a number. So you give me a number on the spot. 1, 2, 3, 4, 5, 6, 7, 8. Give me 8 numbers. Okay, 2.
2, 3.
Okay, wait now. X equals to 2, y equal to 3, sure. Then
3,
3,
5,
5. Next one.
7,
Another one.
1.
1. Okay, let me just fill in the blanks. 3 times 2 is 6. 5 times 3 is 15. 6 plus 15, 21. 7x is 14 plus 3 is 14 plus 3 is 17. Right? I calculate wrongly, I hope not. Okay, so there's our system, our two equations, two unknowns. We're gonna follow the same method. So we write it as a coefficient matrix. How do you write it? 3, 5, 7, 1, square bracket, multiply by x, y equals to 21, 17. So reminder of the formula, it's ax equals to b format. Solving for x, you get a inverse b. But your a inverse is defined to be 1 over determinant of a, which is ad minus bc, multiplied by, let me draw the a first, I can't remember. A equals to A, B, C, D, then A inverse will be, you swap the A and D around, so D here, A there. The B and C, you multiply -1. Okay? Good. Then we're gonna carry on. Sub this A inverse inside there. Multiply by B, and then you get your answer. So let's do that. So A equals to 3, 5, 7, 1. Therefore, A inverse equals to 1 over
1 over A times D, so 3 times 1 minus 5 times 7.
Okay, then don't put times there. So I'll square bracket then.
1
Okay,
and
what's this next
then
one?
negative 5, -7, then 3.
Yes, correct. So basically, this pair was swapped around from this two. Then this pair, you just multiply by a -1. Okay? Good. Then we simplify. This guy is, let me just get the calculator. So 3 times 1 minus 5 times 7 is a -32. Multiply by the whole expression there. Distribute in, then I get -1 over 32. Positive 5 over 32, positive 7 over 32, -3 over 32. Square bracket, square bracket. Okay. Good, that's A inverse. Then what's the solution? X equals to A inverse multiplied by B. A inverse is?
And that one.
That guy above. Copy paste. Multiplied by B. What's B? B is
21, 17.
Okay, very good. So this multiplied by 21, 17. What's the size here? 2 by 2. What's the size there? 2 by 1. So what's the overall size?
2 by 1.
2 by 1, huh? I'm gonna draw a huge space here, a broken line to remind myself, okay, there are 2 rows and 1 column. Fill in the blanks now.
-1 over 32 times 21 plus 5 over 32 times 17. Then bottom is 7 divided by 32 times 21 plus -3 over 32 times 17.
Okay, calculator time. Let's see if we get our answer. -1 over 32 times 21 plus 5 over 32 times 17. I get a 2. Interesting. Next one. 7 over 32 times 21 plus -3 over 32 times 17. Really? I get a 3. Wow. X equals to 2, y equals to 3. Okay? This is really just xy. Is that the same as the answer that what we started with? Yes. So it works. Can understand how to do it? I never explained the why and why the formula is true. But that's the how. You'll learn more in the future in linear algebra in university. Or maybe engineering max part 1. Okay. No reason, just the how. For 2 by 2. 3 by 3, wow, 3 by 3. You need to know the full definition of a adjugate as well as the full definition of a determinant. The A inverse, the original formula is actually over Okay, I write it. So over here, the full formula is 1 over determinant of A multiplied by adjugate of A. Maybe I should write this down. I see A inverse is defined to be 1 over the determinant of A multiplied by ADJ of A. Oh, you'll learn more about what is a determinant and what's an adjugate in the future. I will not explain. Wait for a university prof to explain for you. Okay, that's all for today, I guess. We still integration. Okay, integration. One more thing to mention. I haven't explained this. Jialat. You're supposed to complete the square. Do you know how to complete the square?
In what context?
In question 6, part 1. Okay, sorry. Wait, one more question, Ken. 6, part 1 before we call your day.
Okay.
We solve this. So 2x squared plus 2x minus 3. You divide by 2x squared minus 3x plus 1. When you see expressions of a fraction form, you're supposed to use what's called a LFP method. What LFP? LFP method says you look at ln fraction, partial fractions. Fraction, you have two formats. You either have a linear on top divided by a quadratic below, or you have linear on top, ax plus b format, and square root of quadratic below. For ln, it's basically asking you to look out for f prime x on top, fx below. Yes, and when you have improper fraction, you need to do long division. So let me move this up.
Okay. 1 plus 5x minus 4 over 2x squared minus 3x plus 1.
Oh, right. One more trick you need to learn, the a times something. I think I went through this before, is it? Fx, you see, you go in order LFP. LFP is looking for what? Integrals of the form f prime x on top, integrands of the form f prime x on top divided by fx below. Then this will just be ln modulus fx. Let's see. What does it mean? It means that if, let's say, for example, you have integral of I don't know, cosine x divided by, let me think a bit, sine x. Then this is really just ln of the modulus of sine x. Let's see. Why? Differentiate and you'll find out. Differentiate and you'll know. Let's just assume that this modulus sine x is restricted to a domain maybe 0 to pi over 0 to pi, so that it's always positive. So we can just change the modulus sign to a round bracket, and then it's easy to differentiate. Differentiate ln, you get 1 over sine x. Then you multiply by the derivative of sine x, which is cosine x. Okay, what do you notice? It's just cosine x over sine x, right? So that's what I mean by this formula here. F prime on top is cosine x, fx below is sine x. Then you integrate, you get ln. Okay? So we're gonna try and do that. So fx is this denominator, the entire thing. So I'm gonna let fx equals to this guy first, 2x squared minus 3x plus 1. What I need is a f prime x on top. So what's my f prime first? Can you tell me what's f prime? What's my f prime?
4x minus 3.
Very good. So I need 4x minus 3 on top. How do I get 4x minus 3? Here's how you do it. You always let the 5x minus 4, what you have, equals to a times of what you want plus a constant. Solve for a and b by comparing coefficients. Or substitution if you want. I think comparing coefficient is faster. Let's compare the coefficient of x. Compare coefficient of x. You get 5 on the left. What's on the right? A times 4x, 4a. Can? Therefore, a equals to 5/4. This one need to remember. Need to remember this trick. It's a trick. Then after that, if you want to solve for b, what do? You sub in the a with 5/4. Then now you can compare constants, right? Compare constants, or you just sub in a good value of x also okay. I think comparing constant is fast enough. So you get -4 equals to a times -3 plus b. But wait a minute, I remember what's a. What's a? 5/4. Right? A times -3, that's -3a, and then plus b, that contributes to your constant. So we get -4 constant equals to 5/4, which is a, multiplied by the -3, and then plus b. So solving, what do you get for b? -1/4. Then, so what does it mean? It means 5x minus 4 can be rewritten as a, which is 5/4, multiplied by the 4x minus 3. Then you add on a -1/4. Okay? Yes, no, yes, no? So now you replace the numerator with the 5/4, 4x minus 3. And then you minus away 1/4, all divided by that denominator, 2x squared minus 3x plus 1. Yes. Okay, now you have to integrate term by term. Let's see what happens. Integrate 1 dx plus integrate this fellow here. The numerator is huge, but just write it down. Okay, good. I need more space. I'm going to shrink all this down. So next, we have this guy, right? Do you agree first? Let's say you have 3/4 times 5 minus 6 divided by 7. Isn't it just the same as 3/4 times 5/7 minus 6/7?
Okay.
Same, right? We're gonna do the same thing, but I'm gonna highlight it. Let me use my highlighter. Yellow, blue, green, purple, 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 green, blue, yellow. I forgot the minus. Okay, maybe light blue. Same thing over here. I'm gonna color in yellow. Yellow, blue, light blue for the minus, green for the 1/4, and 7 is the entire denominator here. How can we split this up? Integrate 1 first, you get x plus integral of this guy. Split up, what do you get? Follow the same pattern. Can see the color coding. Yellow, 5/4 times 4x minus 3 divided by 2x squared minus 3x plus 1. I color code for you first. Yellow is the 5/4 you factor out. Blue is the numerator. Purple is the denominator. Followed by a minus sign. Tell me, continue. Highlight. What else you have? Yeah.
Negative.
Follow the color, green over purple.
1/4 on the top. Then 2x squared minus 3x plus 1.
On the denominator. Good. Get it now? Let's split it like this. Okay, then you must remember when you have subtraction or plus, the integral you can distribute into each of them. Integrate term by term. So we end up with integral of, because I have an iPad, I can do this. Copy paste. Yeah, then I don't need to write so much. Okay, and this becomes dx, integral dx. Okay? split.
Okay.
We're gonna split further. This one 5/4 can factor out, left with integral of 4x minus 3 over 2x squared minus 3x plus 1 dx. Minus away, factor out the 1/4 times integral, leave behind a 1, there's an invisible times 1 here. 2x squared minus 3x plus 1 dx. Is it clear so far?
Mm-hmm.
Should I continue highlighting?
No.
No? Can see? You sure?
Mm-hmm.
Okay, good. Then now you just need to realize that 5/4 can leave alone. This guy here, very special. Isn't it just the fx below f prime on top?
Yeah.
F prime x on top. Then that means this equals to what? Ln of modulus of the denominator x squared minus 2x squared minus 3x plus 1. Okay? Ln fx. Remember this formula above?
Yeah.
Okay, good. How about this part? With a minus 1/4 times integral of that guy. Whenever you see a quadratic denominator, what you need to know is you have to complete the square. Complete the square. So here's how you do it. Take a look. 2x squared minus 3x plus 1. It's an expression, it's not equation. So you have to add and subtract half the coefficient. But before that, factor out a 2. I like to factor out 2 from only the first two terms. Leave the plus 1 alone at the right side. Leave the plus 1 alone at the right side. Leave the plus 1 alone at the right side.
Mm-hmm.
Maybe just to make it even more systematic, I'll just put square brackets from the beginning. So this guy is 2 times the square bracket. X squared minus 3 over 2x, I can rewrite as add half the coefficient of x, which is 3 over 4, bracket square, minus away 3 over 4, bracket square. Close the square bracket. What do you notice about the first 3 terms? 3 terms? It becomes what? X minus 3 over 4 bracket square.
Yeah.
A squared minus 2ab. 2 times x times 3 over 4 becomes 3 over 2x. The 2 and 3 over 4 cancel away. Oh, then plus b squared. Okay, then minus away that 3 over 4 bracket square. Close the square bracket. Now you distribute the 2. You get 2 times x minus 3/4 bracket square. Minus away 2 times this guy bracket square plus 1. I don't care what this is. I don't want to do mental sums. I'm just going to use a calculator. So what we end up with is negative 2 multiplied by 3 over 4, close the bracket, power 2, plus 1. Then you end up with a minus 1 over 8. Okay? Clear?
And
I'm going to factor
Yep.
out a 2 as well. So now this becomes x minus 3/4 x squared minus away 1 over 16. Is that okay? Yeah or not?
yeah.
Factor out a 2 so that the coefficient in front of the x is 1. Okay, move on. So now we're going to substitute in the denominator with the final form. Do the scratch work at the side, because if you sub into an integral, it's going to be very messy. Do the completing the square at the side and then just substitute the final result at the end so that the presentation looks nice. Now I copy down everything else. X plus blah, 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 blah. Give me a second to copy this. And then minus away 1/4 of, oh, wait, there's a 2 here, so it's 1/2. Factor out, I get 1 over 8. Right? Maybe I do it step by step. 1 over 4 first, then times 1 over 2, then times the integral of all of that without the 2. I took out the 2, which is actually a half. Is that okay?
Mm-hmm.
So completing a square gives us this format, right? Then what you need to realize is that something x squared minus away a constant minus 1 over 16, isn't it the same as square root 1 over 16 square? And if you're faster, you realize that square root 1 over 16 can simplify as 1/4. But not important. Not important. I need you to see this form first. I remove the square bracket first. Okay, so you got linear x power 2 minus away some constant power 2. X square minus constant square essentially. Then if you refer to your formula list, refer to your formula